Hey, happy Friday, you guys. So first I'll throw out a little pitch. Got one of those little stickers from early voting. So early voting's open. It's a good time to go make your voice heard. So we speak with our dollars in the economy, and in a democracy, we speak with our votes. So go out there, use your voice, vote. Now we're going to do a little special demonstration today because we're talking about firms now. We're talking about making stuff, selling stuff. And again, it's a little bit further removed from our everyday experience, but it doesn't have to be, thinking about Apple making iPhones, right? It can be very, this sort of thing. So I've got with me, I talked a little bit about a neighborhood economy where we're maybe exchanging things like homemade wine and such. So we're talking about what it takes to make something. So here, I'm not working with wine today. I've got this tart cherry juice from up in Michigan. And I've got these wine bottles. So these have been sterilized already. I'm just gonna pour some cherry juice into a wine bottle here. So you could imagine if I were making and bottling wine, this is what I'd be doing, right? Except instead of juice, it'd be wine. Instead of pouring it out of a jug, I'd be using a siphon or something else probably, but same sort of idea. So you don't want to fill it all the way, about the top of the shoulders of the wine bottle there. Then we've got a nice wine cork here. Goes into this wine corker. It grabs onto the neck of the bottle. And there we go. Now we've corked, we've bottled, in this case, tart cherry juice. So, that didn't take me too long. It helped a lot that I had already cleaned and sterilized the wine bottles. It helped that I was just pouring out of a very manageable size container. If I were actually doing something like bottling homemade wine, it would, it would take me a while. So I would have to clean and sterilize a bunch of wine bottles. I would have to get the wine into a container that I can either pour out of, or I would siphon it from that container into the bottles, and then, put the corks into the corker, and then put the cork into the bottle. So if I'm doing that myself, I don't know, let's say I could do about, I'm writing a little table here. People and bottles. If we have one person, let's say I could do 10 bottles in an hour. So that's about what I could do if I'm bottling some homemade wine, probably. Now, if I have a friend helping me and we have 2 people, then it helps a lot, because not only are there 2 hands making lighter, 2 people, more hands making lighter work, but we could also start to specialize a little bit, right? So we can have one person who's doing the cork closure. We can have the other person who is sterilizing the bottles, and maybe we're working together to fill the bottles or something. So with 2 people, we could probably do 30 bottles in an hour. So we're more than twice as effective adding a second person, because we can start to specialize and really get into a rhythm. Now with 3 people, we can keep doing more, but at that point we're now we have one person who's sterilizing bottles, one person who's putting the corks in, and one person who specializes in putting the liquid in. We might be able to do some really efficient work, but let's say 3 people could do 45 bottles in an hour. So that's what, about 4 cases of wine. If we have 4 people, now we're probably starting to started to get in each other's way a little bit. And certainly by the time we get up to 5 people, we're probably not adding that much in the way of the number of bottles we can get. So I made up numbers here, somewhat realistic. 1 person can do 10 bottles in an hour, 2 people can do 30, 3 can do 45, 4 can do 55, 5 can do 60. So we deal in charts and graphs a lot in this class. If we write out 1, 2, 3, 4, 5, so this is the number of people involved. And we write bottles up here on our y-axis. So I just made some axes with people and bottles. And we're going up to 60. So at 1, we're 10. 2, we're 30. 3, we're 45. 4 is 55. 5 is 50. And I'm just going to draw a line in between those dots that I made. That's showing how many bottles we can make as we add more people getting involved. More hands making lighter work. But we can see there's this steep area where we're not only going faster because we have more hands making lighter work, we're getting more efficient, right? We're able to specialize in cool ways. And so our curve is really steep there. Once we start kind of tripping into each other and elbows bumping and knocking bottles over, we have to start being more careful. It means we're not gaining as much as we add more and more people. So with this setup, with this equipment, in this space, 5 people, you add more than 5 people, you're probably going to actually start to lose on productivity, right? Because you will literally be bumping into people. So this is what a total product of labor curve looks like. The total product, meaning the total amount that you're making together based on different levels of labor. That's the number of people involved, or you can have it measured as the number of hours people are working. Now, this same information, we could actually think about it in a different way. We could think about the marginal product. And so I'm going to turn back to our how many 10, 20, how many bottles do we get with the first person? We add 1 person, we add 10 bottles. How many bottles do we add with the second person? Well, we go from 10 to 30, so we add 20, right? How many do we add from 2 to 3? We add 15. How many do we add from 3 to 4? We add 10. And how many do we add from 4 to 5? We add 5. So this is now another curve. This is our marginal product of labor. And so the same data behind it, but instead of measuring the total amount of bottles that we can make with a given number of workers, we're measuring the additional numbers, the marginal number of bottles that we can add from each additional worker. So a marginal product of labor curve almost always ends up having this shape. So we see it going up. That's when we were gaining efficiency because we could specialize. But then eventually, for just about any product, just about any space or industry or technology, eventually, with everything else being fixed, just adding more workers, we're going to start to get less bang for the buck for each additional worker. That's called diminishing marginal product of labor. That fits in with our diminishing returns idea that's actually become kind of a central theme of this course, if you've noticed. We've got diminishing marginal utility for consumers. On the firm side, we have diminishing marginal product. And that's true for labor, it's true for other sorts of inputs as well. So eventually, adding more of a certain input, it's going to strain your other inputs, right? If those are fixed, then you're eventually going to get less bang for the buck for each additional unit. So that's total product of labor, marginal product of labor, and now I have a nice bottle of tart cherry juice that I could either age or I can enjoy now. Hope you guys have a great weekend. I'll talk to you soon. Bye.